So let me do this officially, seeing as we're almost all here. Croeso cynnes, pnawn da, welcome to everyone. Good afternoon to our seminar with Joseph Lewis from the Welsh Government Data Science team, talking today about producing automated bilingual custom data reports. And if you think that's a difficult title, wait till we get into the concepts that Joe is going to be talking about inside. It's going to be a really good one. Juicy is the word I'm using to describe it today. Lots of really good insight coming your way. Just as we get started, please use the chat facility. Have a chat to us, talk to us a little bit. Tell us what you're having for lunch. That'll be fascinating. Tell us what the weather's like. It's guaranteed to be rain, I think. I've had so much rain here today, but I'm interested anyway. And the very last thing, and I'll stop waffling, is that we are recording. So if you are not keen on having your face appear in the recording, please make sure your camera's off for the duration. Okay, I haven't heard a beep for a few seconds of somebody joining, so I'm going to be quiet and hand over to Joe. Croeso cynnes. Joe, warm welcome to Joseph Lewis. Over to you.
Thank you very much, Peter, and thank you everyone for joining. I'm just going to take control of the slides. And yeah, so as Peter said, we're going to be talking about producing automated data reports. So this project is something that we worked on last year, and the reports are still being produced this year. So it's been kind of a project that's kind of stood the test of time, at least for the last year. And I'm really excited to share what we've been able to do. So the focus of the session today is in 4 kind of key areas. The first of those is kind of giving some context and background to what we've done. I'm going to introduce the All Wales core data set, which is the kind of data set behind the reports that we've produced. I'm going to talk a bit about the problem statement and how we've broken that down, some technical objectives. I'm going to then go into the kind of meat of the session today, which is the best tools for the job. So how we chose to use different tools, how they all work together, and how we kind of orchestrated that process using SQL, R Markdown, and JSON files. And then I'm going to talk about the kind of important considerations that we had to make. So things like working bilingually, that's kind of laced throughout the presentation as well, along with accessibility and then quality assurance. And then last of all, I'm going to look ahead, if we have time at the end of the session, to talk about how it's kind of informed our structure for reproducible reporting going forward and what the work has let us kind of achieve. The outcomes of the session today, I'm hoping you'll see how we've automated a very large data process, how we've produced a low-code solution for interacting with what's become a very large code base. This might be of interest if you're doing any kind of transformation internally and helping to kind of upskill analysts and things like that. We're also going to talk a bit about the best tools for the different parts of the pipeline, so you can kind of pick different parts that are of interest to you and kind of take things away and not necessarily have to lift and shift our whole solution. And this might be of use if you are producing thousands of reports like we've done. Our reports go out to hundreds of different stakeholders across the country, so it kind of is quite a nice solution to kind of take and copy exactly what we've done there. But it could also be of use to you if you're just producing one report that you generate frequently. We're looking for kind of time savings wherever we can, and this is kind of a nice way to do that. But it also could be of use if you're building a framework for reproducible reporting, which is actually what we've ended up doing off the back of this project. So that's really positive, and it's kind of informed our approach to quite a lot of other projects. So some context and some background on the process that we've actually automated. I'm going to give what is a very brief introduction to the All Wales core data set, and we're hoping to publish some kind of technical blogs and things in the future on this for some more information. But really, the All Wales core data set, or AWCDS, as I'm going to try and say from now on, because that's a bit of a mouthful, is an umbrella term for a suite of different data reports. They're shared with schools across Wales, the maintained schools and local authorities, and they mainly aim to provide kind of contextualised analysis of attendance and exam results, so that schools have this in a kind of fixed format and they can evaluate their own performance, compare with other schools and things like that. Before we worked on this project, this data was all available in an interactive tool, and this was decommissioned when the AWCDS was suspended during the pandemic. So in 2023, this kind of resumed and the examinations started up, and this was kind of an interim solution to give that data back to schools again. And we wanted to kind of mimic what was done in the previous tool, but we wanted to try to make sure that it was sort of a static report instead of an interactive one, so that schools could have this in kind of a fixed format year on year in the future. And we didn't want to go and develop a full interactive solution, as this was just an interim sort of period. The reports we generated were used in 2023, and now they're being used and generated as we speak in 2024 to try and deliver this kind of data to schools. The reports are made up of attendance data, qualifications outcomes data, and context data. So context data is just pupil characteristic information, things like eligibility for free school meals, and then attendance and qualifications are kind of self-explanatory. But there's a really, really big scale to these reports, and that's what I'm trying to kind of convey across the context that we introduced at the start. So there's roughly 1,200 primary schools in Wales who each receive 4 PDF reports and 2 datasets in Excel. There's 400 secondaries who are each receiving 6 PDFs and 3 datasets in Excel, and then 22 local authorities also receive the 4 reports and the datasets in Excel. As a problem statement that we're going to kind of try and keep in mind over the course of the presentation, we were approached by policy colleagues and statistical colleagues to see if we could build this interim solution and replace this decommissioned software that was sort of gotten rid of during the pandemic to support that evaluation and analysis of learning. We broke that down to some technical objectives to kind of make it a bit more bite-sized and work on things one step at a time. And those objectives that we found were, could we first of all automate the processing of schools data, and then we looked at producing one example PDF report that contained qualifications outcomes data. Then we tried to see if we could scale that up to sort of all the secondary schools in Wales. And then we last of all looked to see if we could extend that out to other data sets. So could we report on attendance data, contextual data, and could we extend the reporting out to primary schools as well and not just focus on secondary schools and the qualifications outcomes data? This is what we are aiming for. So just to give you kind of something to keep in mind as we move through the slides and get into some technical detail, things might get a little bit more abstract, but it's quite nice to keep this in mind as what we're aiming for as we go through. So all the data I'm going to show today is fictional. I made it all up, so there's no worry about sensitivity or anything like that. But you can see on the left here, we've got like a nice cover page, a brief disclaimer and an introduction to what the sort of AWCDS reports are. We also give some versioning information that we sort of pass in to make sure that it's clear that these are the reports of 2023, 2024, and we sometimes produce reports at different months of the year as well. Then we get into the contents page just after that. So this is actually an interactive contents page, which is really nice. So this is the one kind of interactive element that we've got in there. So users using a PDF viewer can kind of click to different parts of the report and get to different pieces of information that they're interested in. And then we've got the kind of most interesting bit of the report, which is the data sets. Oops, sorry, I just got muted. Hopefully you heard the bit before. And we've got a regression plot, we've got a bar chart, and we've got some extra kind of faceted bar charts behind that, and we've got a table just behind that, which I appreciate may be a little bit difficult to see. We then produce the exact same reports in Welsh. So as I said, this is all about bilingual reporting. Schools receive reports in English and Welsh. So there's each of these reports and all of these items in Welsh in the same places as they are in the English. So if you're a Welsh-speaking sort of member of staff in a school and you're working with an English-speaking member of staff, you can still reference the same charts and get to the same information. And there's no difference in the kind of ability to use the reports or the service that we're providing in the reports. To give a bit of a sense of the scale of the reporting, we use one plot to display one breakdown of data. So that could be a bar graph, it could be a scatter plot, it could be a table. And each report has between 20 and 50 plots. Some have quite a few more, some have a little bit less, but 20 to 50 is a kind of sensible range to think of. And those are going to make up one of our reports. Each school is receiving 2 to 3 of these. So depending on if it's a secondary school, they also get that qualifications outcomes data. And they receive all those reports in the 2 languages, and that makes up one data pack for a school. So if I reference a data pack, that's kind of just the entire suite of reports that a school receives. And for these data packs, this is just what the secondary school picture is going to look like. So you can imagine how many reports and charts those contain. And we're talking about quite a really, really large scale of data moving around and a lot of insight that we're trying to get out of it for individual schools and stakeholders across the country. So as a summary of that kind of introduction information, we're aiming to replace that interactive software with static PDF reports. We're only aiming to replace the kind of same information and the same charts and the same sort of analysis that can be performed, because this is just an interim solution. We're not aiming to expand to anything new just yet. We're also aiming to kind of make it easier to expand in future, because we'll sort of be keeping these skills in-house, so we can add new reports in future if the sort of need is there, or to rerun the reports in future years. Our main focus is on making the reports as useful and comprehensive as they can be, but we're also trying to maintain good practice for accessibility and data protection. So you'll see we've done some work to kind of simplify what's in these reports and make them kind of more up to date with modern visualization standards and things like that. So on to what's going to be the sort of main part of the session today, focusing on the best tools for the job and what our solution has been. And we're going to get into some of the technical detail as we go through these slides. So on this diagram, I'm going to move from right to left and sort of explore what we've done to build this solution and layer on extra complexity over time. So we start off with the solution on the right. So we've used ggplot2 to build all of our charts, and we've used R Markdown to build our reports. If you're familiar with either of those tools, they are quite commonly used in R, and we're going to explore them at quite a high level today to show how we've used them. We then wanted to see how we could make this solution a bit more reproducible, and we wanted to make sure that we were doing as much as we could in R and in SQL to avoid having to kind of do any manual effort year on year or to edit anything that we shouldn't have to. So we used dplyr for a lot of our processing among some other R packages and libraries, and we used SQL to store our data and to do some of the sort of selecting of data and a little bit of the processing too. We then wanted to make it as low code as possible. So when I talk about low code, I don't mean that the solution is low code. I mean that it's a low code way of interacting with the solution. So we've used JSON files to store a lot of our parameters and dictate how these reports are built. And we found that really helpful to make sure that new members of staff or people who may not be as familiar with R can get into the code and can still actually make changes and run the process year on year. The last thing that we did is automate as much as we could. So we've done that through one central main.r script, as well as one last JSON file that kind of rules them all, to add those extra parameters in and control the sort of orchestration of the rest of the process. That's quite complicated. So for now, we're going to strip right back down and look at just adding one chart to one report using one data set. So I'm just going to focus on the SQL, dplyr, ggplot, and R Markdown elements. So selecting, processing, visualizing, and then actually adding a chart to a report. We're very fortunate on this project because we're going to start in SQL. A lot of our Welsh Government school statistics data sits on a SQL server, so that makes us really, really kind of lucky, and it's quite easy to select data and take from there in R. We access all this data programmatically using R and the RODBC package. If you haven't seen that before, it's basically just a way to interact with SQL Server or SQL databases in R. So the ODBC connection is what we use to do that. And in the snippet on the left here, you can see we've got a SQL query starting at select date and ending at is not null, stored in a string. And then we just run that query and we end up with the data frame on the right there in R. The really nice thing about RODBC is that we do just kind of write SQL code and then call it in R. It's nothing too complicated. And what I'm going to do really briefly is kind of talk through what the data set is like that we get out the other end. So the data frame that we've got in R on the right here, some of these columns are labeled. That's basically so I can kind of explain what they're there for now and for when we get to the processing. So the school identifier is just a unique number for the school. Again, these are all fictional schools, so there's no sort of real identifiers in there, but these are publicly available, so you could find a school by an identifier online. The next item, the school family number, or school family code rather, is an indicator of what family the school is in. And this isn't anything to do with actual families. Basically, schools that are similar to one another in terms of characteristics and things like that are able to see one another's data, so they can compare and see how like schools are performing in terms of attendance or qualifications outcomes. And that kind of helps some of that analysis within schools. The text EN and text CY labels, just at the top there, we actually return both English and Welsh labels for all of the kind of characteristic information or any data descriptors that we return. And that means that we can keep all our translation in one place, in one lookup table, and we have one kind of central source of true translations. And we don't have to worry about duplicating it or hard coding it anyway, and that makes it a bit simpler for us to work with. The actual value is actually aliased in the SQL query, so the percentage sessions missed is what that is. So this data set is actually to do with attendance. So we're looking at a breakdown of percentage of sessions missed between male and female pupils. And this is the value that we're going to display in our chart, basically. The to suppress column is the one that's kind of the most complicated, but all this is doing is controlling whether we should suppress a value for confidentiality reasons. As I said, schools are allowed to see similar schools' data, but what they're not allowed to do is kind of get into information that they shouldn't be able to see or to work out a pupil's identity from it. So we suppress any values that are based on sort of absolute counts of pupils of less than 5. In terms of managing that SQL code, as you can see on the previous slide, it did inflate our R code quite a bit. We ended up expanding sort of unnecessarily almost because we were writing that SQL code directly in R. We don't want to kind of make it that hard to maintain what's going on, and we want to make it quite easy to edit our SQL queries and select our data. So instead, we split it out into TXT files and then read those TXT files into R and then use that to query SQL instead. So in the snippet on the left there, that's from a TXT file, and that's got our query just the same as it was before. We then read that into R using the read file function and then query the exact same way that we did before. We end up with the same data set that we had before, and there's no kind of sleight of hand going on there. It is doing the same thing. This works really well because we are promoting these low-code interactions. Users with little R experience but lots of SQL experience can still get involved. They can still be part of the process, and they can edit those SQL queries. And it helps us to kind of make our work a bit more reproducible. But I'm going to move on to that later. So sort of bear in mind that the important thing to take from this is just that our SQL queries are stored in these TXT files that we can then read into R. We now move on to processing that data. As I said, all of our general processing is done in R. We do some bespoke processing for some data sets in SQL, which is actually quite helpful because we don't have to worry about sort of generalizing it and writing that bit in R. But for the AWCDS project in particular, almost all of our data sets required us to anonymize some information. As I said, schools are allowed to see other family member schools, but they're not allowed to know which school it is either. So we do some anonymization on that just to sort of replace it with a family member 1 instead of the school unique identifier number. We also do things like calculate relative differences in attendance for male and female pupils. We pivot tables for some of the tables that we display, and we do some other things like the suppression. So that's the code snippet on the right there, which actually suppresses that data for the values below 5 but greater than 0. This isn't the only thing that R can kind of do. If you haven't used R before for data processing, I've listed some of these other more common data issues that you can solve. So things like dropping duplicates, calculating averages, and filling missing values. I've included those there because I'm aware that the AWCDS needs for processing were quite specific. So if there is anything that you're interested in that was sort of more general, then you can do that here too. The example that I've got here is the data that we got on the left, and then we take that through our dplyr and some other packages processing pipeline, and we end up with a nice kind of process data set on the other side. So some of the things that we've done is removed columns that we didn't actually need anymore, that were only used for that processing. We've suppressed some values, so you can see in the middle of the table, there was a value in the toSuppressed column of 1, and we've actually filled the actual value in as 0, and then added a square brackets and a C in as the label. So that's the label that we're going to give that in the plot later. We've also anonymized those family members, so they're in as family member 2 to 8, and we do things like add the color for plots so that that's consistent as well. Now that our data is processed, we can start to think about visualizing it, and we do that again in R using ggplot2. ggplot2 is one of the most commonly used R plotting libraries, and it's how we built all of the charts. So we've done that because ggplot allows you to kind of separate the building of charts into 2 distinct components. The first of those is data. So these are the kind of functional elements of a plot that dictate what a chart is or what it shows. So things like choosing the data set to display, what's going on each axis, is it a bar plot, a scatter plot, whatever it is, and how we're going to scale those axes as well. The other element is the style. So what background color are we going to use? What are the color schemes for the bars or the scatter points? What's the title for the plot? What are the fonts, font sizes, and things like that? This makes it really easy to apply styling consistently and concisely, but then the data and functional elements of the plot can vary quite easily. So you can see on the 2 images of the 2 charts here, the color scheme does differ between the 2, but the other sort of stylistic and aesthetic elements stay the same. So we can build them using their own sort of bespoke code for building a bar graph or a scatter plot, and then we can actually style them both the same way using the same code. So this is an example of that process data set taken into a ggplot function, which really is just kind of 3 lines for building the actual plot. It is quite simple. And all we do is we dictate what's going on the x-axis, our family safe name, our y-axis is showing the actual value, and we're filling it with the text at the end, so that just indicates what we're going to group by, so that male and female in this group bar chart. And we end up with this kind of graph at the other end, which doesn't look too bad, but is sort of not up to the standards that we'd be looking for to display back to our stakeholders. We then layer on our styling elements, and we do that using the CAS style function first of all. In the sort of ad for this session, you may have seen that we posted a blog introducing CAS style R. CAS style R is our package for visualizing up to our kind of Welsh Government external publication guidance. So we thought it was kind of a best practice to do that here as well, and format things. Even though these aren't necessarily being shared publicly, we still wanted to make sure they were as accessible and as clean as we could make them. We also add some extra things in to bring the charts more in line with the kind of previous software that was being used. And that's kind of helped us to make sure that there's no kind of massive stylistic differences between the previous software and this one. There are still some familiarities. And it's quite nice in R because you can layer those on after the original sort of style that we've added and make things a bit different for your specific use case. We also add a color mapping. Again, these are dictated by our analytical function and our internal guidance to make sure that the colors are accessible. We do use a few different color schemes, and I'll talk about that right at the end. And then we also scale the x-axis, which sort of sits in the middle ground of style and data. Next, we're going to move on to R Markdown. So R Markdown is a library that allows us to actually create these reproducible data reports. You can produce reports in PDF, you can make them in HTML, you can make them in Word, and there's probably some that I've missed out of that. So if you are looking to produce any kind of report using R, this is a really nice way to do it. Everything you can do in R, you can do in R Markdown. So all of this work that we've put in so far to build charts, query data, process data, that's all still relevant because we can do it in R Markdown. And you might be familiar with LaTeX formatting from other LaTeX report editors, but we can also do some stuff with LaTeX formatting in R Markdown. Some of the things that you can do, as I said, is display visuals like the charts we just plotted. You can use Markdown formatting, which is really handy and really quick to get into. So you can add bold, underline, bullet point, all the things you'd expect to do with a kind of normal word processor, but you can do it all programmatically. And you can also create a reactive table of contents, as I mentioned, so users can click links and navigate through the reports. Some example R Markdown report pages are given in this one. So on the left, you've got the code to generate the report, and then on the right, the report that's been generated. So you can see you get some kind of front matter at the top, some parameters that you want to add in. You've got a title that you give the report that then displays as a kind of header on top of the report, and you've got the output document, so for us, PDF documents. We can also add kind of titles and text directly in Markdown before any code has been written. So this is a cool Markdown report as an example of a level 1 header in this report. You can add text directly from R, sort of programmatically adding that in, or you can add the stuff that we've done so far to get data, process it, and then build a chart. So that's the code that we've seen so far during the session. As you can see, this report is pretty good and it looks okay at the other end, but it doesn't quite match what I showed at the start of the session. That's because there's some extra LaTeX commands and packages and things that we add into that front matter to make sure it's a bit easier to work with, or a bit more accessible actually, to sort of review the report afterwards. So this is sort of more in line with our own style guidance. It sort of looks something like what you'd see from an external report if you've used any of our external stats reports. And that kind of helps to, again, bring this kind of stylistic idea together. This looks like a Welsh Government report and enhances the kind of user experience with that one. Now that we've got a chart added to a report, we can start to think about how we scale up. And we do that mainly using JSON files. And this is the simplest way we could think of doing this. So I hope it will be useful if you've got a similar problem. To recap, we've covered querying data from a database and processing it. We've looked at how we use that data to build charts, and then we've looked at how we add those charts to reports. What we haven't covered yet is how all of that glues together, how we control what is built, how does R know that we want to build a bar chart here, and what data we should use to inform that chart, as well as what order to put it in a report. So we start off by kind of generalizing our idea of what goes into a report as an item. So these are like the fundamental kind of building blocks of our report. So they could be titles and text, charts and tables, or they could be page breaks. So as an example, the items that we've got here are the title at the top of the page, so the number 1 attendance data, and then we've got a second item, which is the chart itself. These items need to know how they should be displayed. So R needs to know what to sort of include in these items. So for a title, for example, we need to know what text we're going to display, and we need to know what level we're going to show it at. So a heading level 1, 2, or 3, similar to the kind of section titles you might use in Microsoft Word. A chart needs a lot more. It needs a lot more parameters to dictate how it's built. It needs a title, which is quite a simple one. It needs to know what variable it's going to group by, how should the points be sort of colored, where the regression line parameters are going to come from in the case of a regression plot, what variables should be shown on each axis, what's the data behind the chart, the sort of really fundamental components. You know, what are we plotting? Is it a scatter plot? Is it a bar graph? Is it a histogram? And we also need to know what filters we should be applying to the data, if any, for that processing pipeline. We've done this using a JSON file. So each report has its own JSON file. So you get each item has a type. So for example, the type text item at the top of this, and those items also have parameters. So for example, text body, number 1, attendance data. So that's what we're going to display in the text body for this item. You've got a heading level, so 1, 2, or 3, and that indicates how many hashtags we're going to pad with to give that title in Markdown. And then we've got a second item type of a line chart. So the line chart, again, a lot more parameters in this JSON file pulled through from the last slide. So we need to know what we're trying to plot. A single line chart is the sort of name that we gave this. And then you've got the variables we're going to show on each axis, an X variable and a Y variable. You've got a group variable, so what you're going to actually group by, what should be shown in the legend. You've got the title for the chart. You've got the filters that you're going to apply. We only want to show school, family member, and family average data in this chart, for example. Where the regression line parameters come from, that's a bit of a complicated one because that actually references another JSON file full of regression parameters, but that's kind of looping around a bit too much. And then we've also got the data behind the chart. So this is the source item there. And what's really nice about this one is this is where it ties back to our idea of writing SQL queries and text files. We can easily reference what text file that's coming from, and we don't have to write SQL code in JSON and mess around with different formats. We can quite easily reference what's there. So as an example of that pulling through into R, we start off by taking our type into this config type variable and then our parameters into our config params variable. We loop through all of the items in the report. We check what type it is. So this is of type text. And then we've got our code to actually build from that then. So we pad the hashtags, as I said, with the depth, and we add the text body into this kind of string that we're making to add the title to the report. We then scale that up significantly for the report. So this is what an entire parameter file looks like for a report. And this is that kind of outer loop that I mentioned in the code snippet above. And that's what the report looks like out the other end. So now we've got something that looks a lot like what we were building at the start of the session and the idea that we tried to keep in mind through the session. This is the same thing in Welsh. So we've got a Welsh version of this config file, and keeping these config files separate as an English and a Welsh version is a kind of intentional decision, because it means that those who are sort of translating Welsh titles or working in the Welsh language can kind of translate them and add them in as titles here. And we can also reference the Welsh lookup column, so that text CY field we had before can be referenced here and then pulled through into the Welsh version of the chart and not sort of duplicate the length of a file. Next, we're going to think about scaling out. So we're going to review how we achieve that higher level of automation to produce reports for lots of schools in one go. So far, we've produced a whole report and we're looping through items quite easily, and this is still quite nice. So what we're going to do now is think about sort of adding some complexity into that and thinking about how we get reports generated for every school. We've got all our code, our data, and our parameters together, so we know how we're going to build stuff, we know what informs the things that we're going to build, and we know what the rules are to build them, what the parameters are to build them, but we need to think about how the user is going to interact with that and how we do achieve that sort of loop and that automation. We've done this with a main R script, which sits above all our other files. This is hopefully the only thing that a user of the pipeline will have to see. I've put hopefully because there is still a chance that something could go wrong and there could be errors, but obviously those are sort of logged and found in the quality assurance stage. So we hope that the user only has to trigger the main.r pipeline and build each report, and that's where our real scale comes in. So the main R file essentially is just one big loop containing a few smaller loops. So for each report type in the reports that we're going to produce, so we have 6 reports, for example, for the secondary schools, an attendance, an exam results, and a contextual data pack. And each of those are produced in English and Welsh, so that's 6 total. And then we've got for each school in the schools that are going to need this report, so roughly 400 secondary schools are going to need this, so this loop runs 400 times. And then we've got the create a markdown report. So that's just like the sort of idea of creating one of these markdown reports, which itself is a loop creating each item in the report JSON file and adding that to the report. I appreciate that the loop idea was quite abstract, so we're going to think about how we actually add that glue and how it all comes together. So we do that through this central main JSON file, and this is hopefully what will sort of consolidate all the different components that we've talked about so far. This last JSON file is kind of where we get those extra parameters, the last few parameters that we actually need to update year on year. All of the JSON files that we've built so far stay fairly static between years unless we want to add new items to a report or unless there are new changing requirements that we need. But each year there are some parameters that are going to change. So things like the list of schools that we produce reports for, schools open, schools close, schools merge, so different things like that might change the list of schools that we need to produce reports for. There's also different academic years that we're going to want to filter to. 2024 needs to show 2023 data instead of sort of older data that's no longer relevant. We need a title for the report that might change in different years, and we need an indicator as to whether the report should be produced in Welsh or English. This again is helping our commitment to low code. Users can edit these parameters in this main JSON file. You don't need to be an R expert to run the process, and the maintenance obviously is slightly different. And this is what that looks like. So I've tagged everything here with the different aspects that we've talked about so far. We start off with a file name for the report, and this is just, again, pretty simple, just a name that we're going to add to this report seminar example in this case. And then we've got the directory that contains all of our queries for this report. So this is that SQL element, and this is where we're going to get all of our different queries from, so we can just reference them as relative file paths later. We've got the years that we're going to filter data to. So for that data processing, we do some filtering to make sure we've got the relevant years included. We've got the JSON file that contains the structure for this report. So this is those kind of items that are added. We got the name of a markdown file. I've added that in there because there are some different markdown files that we use. Some of the reports have a couple of bespoke elements in there, but I'd be happy to talk about that if anyone had any questions at the end. And then we've also got a list of schools that we're going to loop through in that main R file. So this is where that automation is coming from. This is the loop, the big loop, I guess, that we go through to add every school and a report for every school. And those are all the parameters that we actually need to run this year on year. And we actually loop through each one of these blocks. So the first sort of curly brace section and then the second curly brace section as we go through the reports. So this is how we know what reports we need to make. And the second example there is the exact same thing, but this time in Welsh. So we've got the Welsh parameters to generate the Welsh report. So that's the end of the kind of technical part of the session. We're now going to think about what the important considerations were for us on this project specifically, and how we sort of addressed those. So the first one, of course, is working bilingually. Hopefully you've seen through the presentation how we've used Welsh and how we've tried to make it sort of as easy as possible, both to actually integrate the Welsh language into the process, but also for users who are hoping to use the reports in Welsh and in English. But what we tried to do is obviously double the volume of reports and data that we're using and that are being produced, but we wanted to avoid doubling the amount of code that we've used to still make this process quite easy to maintain. So we've done that by using the lookup tables that sort of, as much as possible, replace items within charts. So things like legends, axes, labels, and notes. So we replace those with their Welsh equivalents there. And again, we've got that central source of the translation in the lookup table. We also use that Welsh JSON file, which matches the English file, but with the translated chart titles and a reference to the Welsh columns instead of the English. So that is a slight duplication in there, but it makes it much easier to maintain and sort of look after these two files separately. We also add a parameter to the high-level main JSON file, as I said, that indicates whether a report is Welsh. And then there are some instances where we've hard-coded the Welsh language instead of English, but those are really limited and often in like really specific situations. But it's still helpful to just have this indicator to use to switch between, rather than relying on some logic that might not quite get caught. In terms of accessibility, we're committed to producing accessible, easy to interpret and clean charts. That's meant simplifying the original charts quite significantly. The original software was, of course, interactive, so you're able to take sort of less precaution around those sort of like the simplicity of the chart, I guess, because you're adding those sort of interactive options in and users can filter and drill down to information. But as we're using static charts, we wanted to make sure they were clean, really easy to understand, and you can navigate to different parts of the report quite easily. So we've done that by applying our Welsh Government and our ONS style guidance. So we formatted all of our reports in line with that external guidance, as I mentioned, and we've done that using our CAS style R package. So CAS style R is a really nice package that we developed, myself and Aaron Nyberg, who might be in the call. Hi, Aaron, if you are. But we've got this package is available on our GitHub. It's being used across our stats department at the moment, and it does help us to sort of apply all that style in. The sort of CAS style line that we saw before is actually roughly 100 lines probably of code of sort of ggplot theme. So just adding it in one line is much simpler than adding that in 100 lines in our work here. We also consider the use of different colour schemes. We've used 3 colour schemes across these reports, but what we have done is tried to limit each report to only one of those, or at most 2 of those different colour schemes. So the primary thing that we use is the accessible colour scheme. So this is the one that we've got as our external guidance. Again, the sort of ones that we use for our statistical publications. We've got some charts that show a lot of variables, so those kind of accessible colours aren't necessarily, don't really work in that case. So what we've done there is labelled everything as best we can to make sure it's quite clear where information is. And we've also added some colours semantically, so things like showing Wales in red, showing local authorities in green. And this is again to bring it in line with the previous software in some cases for things like exam results. In terms of quality assurance, a sample of our reports are checked in detail by our school information policy colleagues. That's before anything is shared externally. And this helps us to pick up those data specific or stylistic issues. We kept an issue log to track that. And I'm really, really grateful for our school policy team and our stats colleagues for being part of that process. We also made use of the log for our package in R, and that helps us to log messages with its SQL or R code errors. Anything wrong or to track missing data is kind of easy to track then in that central log file. We maintain one extra log file, which is an Excel file instead, and that helps us to just track the number of files that we're producing. We don't want anything to go astray and into the wrong folder and sent to the wrong place, so we track that and help to validate that information. We've also got the raw data reports, which we produce into Excel that I mentioned very briefly at the start. The raw data reports contain all the data behind the PDF reports for schools to perform their own validation if they suspect something's gone wrong. Really briefly, I've got 2 slides left on just looking ahead, and then we'll get to any questions. But the main thing that we found on this project specifically, the main benefit that we've had is a real cost saving for the school learner information policy team. This was previously a contracted piece of work. We've used open source software, and we've used resources that we have internally to develop this solution. So there's been a real cost saving, and we're really pleased with that. We've also got a benefit of using our internal skills and our internal tools to build this. This solution is more future-proofed. As happened with the last one, the software was decommissioned and unfortunately not picked back up. We can maintain this and we can run this in future if we need to. It's also easy for us to add new report types. It's easy for us to add new data items to reports and to perform maintenance. I sit a lot closer to the school statistics team than a contracted provider would do. The reports last year were shared with every primary and secondary school as planned, with minimal delays. There were some delays, but they were very, very small. And the sort of new process is being used for the second time this year, and this time everything is going really, really well. The process has been successfully handed over to the school statistics team. They're maintaining the SQL code and the JSON files, and they're having some initial support to kind of review and add further features to the code. The lasting impacts of the work, as I said, this has served as a template for us for a wider kind of reproducible reporting that we can lift and shift to the end of a lot of projects. Once you've done hard work modeling, once you've done hard work producing a data process, the last thing you want to do is spend time thinking about how the report is going to come together. So it's been really helpful for us in doing that. So some of the things we've done that for is experimental work using LLMs to summarize documents, as well as some work in a different team in the organization performing text analysis of a corporate survey. The last benefit that I'm going to really briefly talk about, because I think I've talked about it too much already, is CAS-style R and the other generalized code that we've been able to develop off the back of this. It's now in use across our statistics department and really widely across different publications. So again, thank you all for listening. I've got some extra slides that I'm going to try and just skip past that I kept in if there are any questions, and I'll move to the any questions slide. So if anyone has any questions, please do raise your hand. If there are any in the chat, then please let me know what hasn't been answered already.
Diving in. Thank you very much, Joe. That was great. Really, really fascinating. It's great to see the process all the way through and the wraparound around it and all that. So thank you, thank you, thank you. Really interesting. There've been lots of comments in the chat, but your colleagues have been diving on to answer. So I think at the moment they're pretty much all answered. I know there was a question right at the beginning from Jane. Hi, Jane. Nice to see you here. About providing the PowerPoint screenshots, please. Now, normally in these things, we tend to just share the URL of the YouTube recording, but I don't know if that's a possibility, if you're able to share those PowerPoint files.
Yeah, if anyone's interested in the slides, our inbox, I'll post in the chat, unless you want to just kind of distribute them anyway. But if you are interested or any questions after the session, we're data science unit at gov.wales. So I'll post that link there. And please do send an email across and we can send anything through. Brilliant.
That's very kind of you. Thanks, Joe. Okay. I think, let me just check. Scrolling. Lots of comments there. There's one question towards the end. Jane, where is DEWI involved with these analyses? Where are the Key Stage 4-5 results released to schools, bearing in mind schools' IMS databases provide this data? I don't know if you can come in on that.
Yeah, I can to some extent at least. So obviously we're kind of developing the technical part of this solution. So the wider context, some of that we're not too sure on. So I'm not sure about the IMS databases and things like that. But at least I know that DEWI is used to kind of like as a software to send out the reports at the end. So we use that as a secure exchange service, and we use it to get the data in originally. So I will, if you want to send over your email, I can get some more information on that and send that across afterwards once I get in touch with our school policy colleagues to answer that a bit better.
Thank you. Jane, do you want to come in and add anything to that? And do you want to clarify anything, or is that okay?
No, thanks very much, Peter. Nice to see you again. Let me put my screen on so people can see my face. No, it's just that there's so much analysis coming out of schools at the moment. And that's my worry, where we are duplicating possibly the information that's coming from Q and WJEC particularly with Key Stage 3, Key Stage 4 results. Obviously, the Key Stage data is no longer there, but within the MIS systems that our schools use in Neath Talbot, we've got a tremendous amount of analysis within the software. Are you engaging with those software suppliers?
At least not in our team to develop these, but I can't speak to what the school policy team is doing, unfortunately. Again, we're kind of focused on the kind of technical elements of this bit of the project, I guess. But again, please do send over your email and we can get in touch with the school policy team if you wanted to talk in a bit more detail about the kind of wider context of the reports or the data the schools are getting.
Okay, thank you.
Thanks. In terms of the regression, I can pick up that last question before we drop off unless there's any more. So the regression is actually done sort of in advance of this process. So we don't perform the regression as part of this pipeline. It's done as a sort of another process in the stats team. So I'm afraid that's another answer where I'm going to have to refer back to the sort of stats team and work out any of the sort of information around that. But we can, like, we could automate that potentially to answer that question, that part of the question at least. R is quite easy to sort of perform those parts of the analysis. So we could definitely add that in, but we would have to add some stuff in it to make it robust and make sure that we were doing the tests properly to make sure it was right. There's one more as well. What we use experience with using the JSON files. So on this project, the experience using the JSON file has been quite positive. So we've used JSON files in a few different kind of reproducible analytical pipelines that we've got. And a lot of them in the kind of stats teams have gone down quite well. It's quite like a nice format to navigate through and add things in rather than having to learn where to do it in R or where to do it in Python if we've used Python. But in other projects, we kind of aim to maybe add some sort of front end onto it. So we've done things like Streamlit in other sort of teams to kind of add like a nice sort of wrapper around the process to make it a bit easier to use for people who may not have seen JSON files or may not have even opened things like VS Code before to edit them. One of my recommendations, if you are going to use config files and JSON files for this sort of thing, is to try and do it in VS Code if you have access to it, because it does add the kind of syntax highlighting and things like that and make it a lot easier to do.
Okay, I think that's all the questions. Well done, Joe. Thank you very much. You've definitely deserved your pot noodle for lunch now. Time to disappear. I think that's brilliant. Oh, slides are moving already. So yes, thank you, whoever's moving the slides. There's a little QR code on the screen. We would love to hear more from you about how you thought today went from a CDPS sort of production point of view in terms of invites and getting the links and it all working. We'd love to hear all about that. But if you have any comments about what the content was, or you want more, tell us please by diving into this survey. And there's two last quick things from us. One is, if we can move on to the next slide, the next webinar, I don't think we've got a title agreed yet, but get this date in your diary now, 12 p.m. again, but on the 20th of November. So you've got a month to clear your calendar. It's a lunchtime. By all means, bring your lunch with you, but it's 12 p.m. on the 20th of November for the next one. So that's a really important date. And then final thing, this is an in-person event that's taking place up on Anglesey next week. We are going, so CDPS is going to be there, but it's a Digidol 2024 event. Welcome to sign up and come along and talk to us and join in the conversation about digital. I'll be there talking about our leading modern public services leadership academy, essentially, for everybody delivering public services in Wales, touching on all wonderful things to do with digital. Elise put the link in the chat. Thank you very much, Elise. Okay, I think that's it from us all. Many thanks to Joe and the team from Data Science in Welsh Gov, and all colleagues on the call. Thank you very much for joining us. Much appreciated, and we'll hopefully see you next time. Hwyl fawr, diolch yn fawr.